All right, thank you very much for the introduction. Hi everyone, I'm Mihnea Cătuți from Energy Policy Group, an independent think tank based here in Bucharest, focusing on energy and climate policy. You're going to be stuck with me for the next 2.5, 3 hours. We're going to have a very interesting dialogue and then 2 panels, one after one, right before lunch. So I appreciate if everyone stays with us. If you have any questions, signal it. I'll try to bring them on to the panelists that we have. But with that being said, I wanted to introduce to the stage Mr. Joachim Saalmueller, who's the head of user support and climate services division at EUMETSAT, with whom I'm going to have a 15 minutes dialogue. Yeah, thanks for joining me on stage. You have a short presentation for us, I believe, that you wanted to start it off with, and then perfect.
All right, thank you. Good morning, everybody. It's lovely to be with you here this morning. So we are an intergovernmental organization based in Darmstadt in Germany with 30 member states, among them Romania. So I will quickly give you an introduction to the topic of weather and climate monitoring for the renewable energy age. So let me start by this. Stephen Belcher from the UK Met Office called weather the fuel of the future in a recent BBC interview. So what it requires ultimately is an unprecedented ability to monitor and predict energy relevant weather parameters. And I will give you a few things that we provide into this equation. We are monitoring the weather and the climate, so we are not the predictors itself. So we give these data to the ones who run prediction models, but I'll come back to that. So where are we at? So this is the renewable share, that is essentially the green and blue bars versus nuclear and versus coal and the other non-renewables, I would say. So what you can see is that in Europe, it's the dominant part of the electrification or the production, if you want, and in Romania, this is Romania. So here you have it very dominant last year, and it has overtaken the other energy sources already long ago. Now, this is what we are. So what we do is operate weather satellites in different types of orbits. You see them on the right side. In geostationary orbit, which lets you basically monitor the weather at shorter time scales, and then at global scales through lower Earth orbiting satellites, and these are inputs for numerical weather prediction models. So we operate these satellites since the late 1970s. So we have built up a treasure of data that can be used to analyze also energy relevant applications. We cooperate very much with other satellite operators, so with NOAA in the US or with JMA in Japan or with CMA in China, to actually complete our data with other people's data and then make them available to an organization that is called the European Centre for Medium Range Weather Forecasts in the UK, and they basically run what we call reanalysis. So they stick all these data into the weather model, and they run this weather model over decades, so since 1950. So they create essentially a coherent picture of the atmosphere for the last 70 years. We also run 8 satellite application facilities which develop added value products for various applications, including for the energy sector. I will just give you one important product here that is of very much relevance to photovoltaic yield assessment, and that comes from our climate monitoring satellite application facility. It's essentially called SARA-3, so this is a surface solar radiation climate data record, and what you can do with it, you see on the right side, you see the Earth disk, and so essentially that product is available for the whole of Africa, for parts of South America, for Europe, very much so, and for parts of the Middle East. I dropped the reference here. Essentially all that you need for a first assessment of what you can expect in a particular location in Europe, you have all the data in there. Of course, if you plan a bigger photovoltaics project, you need to have in situ measurements for a while as well. There is best practice examples of how you do that. So we are only one data source, but a very reliable and a very well validated one. This is just one application of this data set. This is a service of the European Commission that is called PVGIS. This allows you to do a first guess globally on your PV installations. I did it here for Bucharest. It spits you out a sort of seasonal timescale of what you can expect every month based on a couple of parameters that you put in. And this service is used by about 500,000 users monthly. 500,000 users monthly use this service meanwhile. So this is showing how much you can do with these kind of data sets. Of course, what you can do as well, you can do climatologies on the top left here. That's for Romania. You can do trend analysis at the bottom left here. So essentially, you have a positive trend in terms of watt per square meter per decade over Romania. And you can do monthly anomalies. So you see that you have months where you have purely positive anomalies. I think this is July of this year. And you also have months with somewhat positive and somewhat negative anomalies, which is May of this year in Romania. A little bit on wind as well. We are not as strong on wind. I come back to that a bit later on. But what you need, at least when you want to do global analysis or very much regional reanalysis like over Europe here, you need reanalysis data sets and in situ data to have a coherent picture of wind development over decades and at the relevant turbine heights. So what we use mostly for this kind of analysis is a global reanalysis that is provided by ECMWF. That is called ERA5. It's one of the most popular geophysical products in the world. And for this particular analysis done by the German Meteorological Service, it is a regional reanalysis at a higher resolution, so 6-kilometer resolution, that is called Cosmo Rea 6, has been developed as part of an EU-funded project as well. And you see, you can do all sorts of anomalies of the wind over particular years. What you see here is the 2023 anomaly over Europe when it comes to wind at 100-meter turbine height, and you see that for Romania, if I interpret it rightly, it was a strongly positive year. Now, a few other things on wind. So our satellite products are particular products, and some of them work only over the ocean, some work over the land. Normally what we derive over the ocean is parameters directly at the sea surface. So this is not directly the turbine height that you may want to have. Of course, these parameters are very important when you want to talk about sea state. So when you want to build or maintain your wind park, the wave heights are extremely important. So we have products for that. But normally you need something that gets you to your turbine height if you want to do yield assessment. What you see at the top right here is essentially sediment transport at the basis of your wind park. So if you want to do environmental impact assessment, it's quite interesting to see because you change the ocean dynamics by the foundation of the thing. So just be aware, there are products out there that you can use in order to talk about sediment transport in the ocean in your wind park. But also we have first evidence, this is from an ESA satellite, essentially Sentinel-1, that shows you the long distance impact of the wind park over the ocean. This is also important for your assessment, in particular if you're close to shipping routes. Now, I think what is important, and it came up this morning already, I think it's very important in the age of misinformation to have the right evidence basis. So you also have to talk about the shortfall risk of the renewables. And this is just something that came up in the previous panel as well. So the complementarity of wind and solar. So this is a study that was put out by a colleague called Frank Kaspar from DWD that shows the capacity factors of wind and solar over an average year based on the 1995 to 2015 climatology. And what you see with the black line essentially is that these things over Europe complement each other very, very well. So if somebody says, okay, you will have a lot of outages based on that, yes, there are days, there are complicated days on the combination of these two as well, extreme events. But on average, they complement each other very, very well in Europe, in Germany as well. This is just another example of analyzing the shortfall risks. This is looking in a German study at the capacity factors under particular weather scenarios that we call Großwetterlagen. This is a term, I think a German term, that made it into the English language. And essentially what they did was that they identified for Germany that the most complicated weather situation you can have when you look at renewables is when you have a persistent high pressure system over Germany in winter. So then you have low capacity factors for both wind and solar. The good news is that in other parts of Europe, when you have that situation, you have more capacity factor for wind and solar. So you don't have this Großwetterlage affect the different parts of Europe at the same time. So it speaks very much to the need to have an interconnected grid and to let you balance these effects over Europe, over the entire European grid. Okay. So what is next? So we have just launched a satellite called MTG. This is our next generation Meteosat third generation satellite. So it's a geostationary satellite. I'll show you some imagery for Romania in a minute. And we have an unprecedented resolution and space and time. And what you can do is you can feed artificial intelligence models with this data. You can feed your nowcasting models for solar power generation predictions in the next few hours and days with these data. We'll launch another satellite in the mid next year that gives you a better articulation of humidity in the atmosphere that will also improve short-range forecasting. And finally, in 2 years' time, we'll launch a satellite called, or a series of satellites called CO2M, by which we will be able to monitor greenhouse gas concentrations first, and then through a model we'll be able to get back to the emissions. So I think for power providers that emit a lot of CO2, it becomes much more visible in the next few years, okay? So countries will have a much better way of assessing how much they really emit, not only based on, let's say, emission inventories as they do them today, but with real measurements. Now, this is just, let's see if that animation works. No. Can I ask the people operating this to start this animation? Guys? Can you start the video, please? All right, in the interest of time, this was unfortunate because this shows you at 10-minute intervals what happens when you have a valley fog in the Carpathian Mountains, how it dissolves. So if you want to know really how the cloud cover changes during the day, this is a very important tool for nowcasting the weather. So for PV in particular, this is a very important tool based on our newest satellite. So I think in summary, what I would say is there is an urgent need for partnerships between the energy sector and meteorological agencies. This is recognized at the global level. I just put out a tweet here from the president of WMO that is forging a partnership also with the International Renewable Energy Agency. But it is very much needed at the national level as well. And there, organizations like Meteo Romania, your national meteorological administration, is very important. They hold all the data. They run numerical weather prediction models with interesting data for the energy sector. But there's also highly specialized private companies that do this kind of advice. So normally our data are important to be integrated into a wider set of tools and prediction models. And you need service providers for that in the energy sectors. And of course, you have to do it based on best practice data. I referenced here a best practice document from the International Energy Agency that is very particular to PV applications. And finally, I think we have to realize what we protect with the whole decarbonization of the system. I mean, if you ask a child how thick the atmosphere is in that image, they will say, maybe whatever, a few inches to the right here. But what it is really, if you look at this here, that's what you're protecting. Here you cannot see that essentially. It's so thin that the bare eye cannot see it. But this is sort of the convection over India that you start to see here over the Gulf of Aden. You can even zoom in more. here, this is convection over India when you look at our imagery. So this layer is super thin. So that's what we're protecting through the whole energy transition. Okay. Thank you very much.
Thanks. Can I have a seat? Yeah, fantastic. No, thank you very much. It's a very interesting presentation, and I think that the service and products that you supply are essential, especially as we increase the share of renewables into the power sector and try to integrate them, forecast, understand how weather impacts production, and then what different changes need to be done in the energy system. You mentioned towards the end of your presentation the need for partnerships, and I wanted to ask you a bit about what steps do you take to make sure that this type of data is accessible for companies active in Romania, but also perhaps what challenges you have faced when it comes to accessibility of data, especially in the region.
So I think the data accessibility is pretty much solved. I mean, we operate open data, so I think pretty much everything I showed you is open data, and we serve them through standard interfaces like APIs, downloadable services. We even have very high-grade distribution system for near real-time applications. So I think the data dissemination equation is pretty much solved. If you want to do larger scale analysis where you need a lot of compute, I think that's where you may have to invest a bit into either a cloud-based service or into your own infrastructure. But I think the much bigger topic is that you get the right skills across different sectors into a national partnership. So it means the sectors have not talked intensively with each other in many countries, and I've seen it emerge in Germany over the last 10, 15 years. What it started with was essentially projects where you tried to tune the model output for a weather model very much to energy needs. And these are things like, what is the hub height of a wind energy plant? Is your forecast good for that? Have you validated these data? How sure are you? So this is where it started, if you want. But meanwhile, I think you need a lot more than that. You need the national energy regulators in the room. You need the grid operators in the room, because they all have very, very pertinent questions pertaining to what is the decadal trend of your temperature? What is your decadal trend in climate prediction? Because we are aiming at a completely different energy system design in 2050. So the level of partnership you need to design is quite extensive, and you need to do it. Because relying on, let's say, individual short-term kind of partnership, I liked very much the marathon notion from this morning, because it's absolutely true. If you see how long you have to invest to turn that system around, we're speaking definitely of decades. Mm-hmm. Now, we have very ambitious targets already in the EU for 2030, but also for 2050. So I think this partnership building across sectors with the right meteorological and climatological information in the room with the power companies, the regulators, and the network operators is the first step.
Fantastic. No, thanks. You mentioned the regulator. I think they're going to be on the panel right after this. But I'm curious about how the work your agency does influences policy making already, and how do you see this type of collaboration further evolving in the future?
I mean, on the policy-making side, I think some of the examples I've shown you about the complementarity between wind and solar, for instance, is an important information. It's an important evidence basis to inform policy. Mm-hmm. Now, in nature, EUMETSAT is scientific and technical. We are not a political organization, so we are very much about operating the satellite, the data streams, the scientific quality of the product. So what we rely on is our member states to take up these policy questions, right?
Fantastic. And for the final question, because we are a bit behind time, I just wanted to ask you about the future. You mentioned already a bit the plans to expand the types of services that you do to greenhouse gas emissions monitoring. I think that's incredibly important. I think it's probably going to contribute quite a lot to the effectiveness of the EU ETS going forward. But I'm curious if there's other developments that you foresee in satellite meteorology that could help better integrate renewables going forward.
I mean, one of our primary roles in the meteorological value chain, if you want, is to supply the best observations to those which do numerical weather prediction. Mm-hmm. There are very fast developments in doing numerical weather prediction next to AI-based weather prediction. There are really some, I mean, there was a recent storm in the US passing over Florida, And the landfall prediction of that storm were so precise from the AI model that really that revolution that is happening in not only in the general AI sense, but in our community is to be watched. So it means that I think we will do massive advances with our partners in the quality of our predictive capabilities over the next 1 or 2 weeks of a forecast timescale. So that is something to really watch in the next few years.
Sounds very exciting. Thank you very much for taking the time for the presentation. Yeah, with that, I just wanted to give you a quick round of applause. Yeah, and
thank you very much.
Appreciate your presence. I'm going to switch to Romania now, so I know we have simultaneous translation.